Have you ever wondered what makes a plane stay up in the air? The secret lies in 4 different forces that have to work together to make an airplane fly. The 4 forces that keep an airplane in the sky are lift, weight, thrust, and drag. First is lift. Lift pushes the airplane up. The shape of the wings helps create lift, but the way the air moves around the wings is the main source of lift for an airplane. Next is weight. Weight pulls the airplane towards the earth. Airplanes are built so their weight is dispersed from front to back, which keeps the airplane balanced. The third force that helps keep an airplane in the sky is thrust. It moves the airplane forward. As you might have guessed, an airplane's engine is key for giving thrust to airplanes and in keeping the air going over the wings. The fourth and final force is drag, which slows the airplane. Airplanes are designed to let air pass around them with less drag. So now remember, all 4 forces are needed to work together to keep an airplane in the air. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
As an aerospace engineer, students have asked me this question a lot. Going to the bathroom in space is not and has never been a glamorous process. During the early Mercury missions in the early 1960s, astronauts used a bag collection system in single-man capsules on short missions. As NASA continued planning longer missions, they needed better plans for astronauts' bathroom needs. During the time of the first Apollo missions, astronauts used collection bags stuck with adhesive pouches and an attached hose that released their waste into space. Today, going to the bathroom in space is a much more efficient process that requires space toilet training. NASA's retired shuttle program had toilets that used airflow to draw waste away from the body. The International Space Station uses a similar design. Solid waste eventually gets burned up in the atmosphere on spacecraft. Currently, the International Space Station uses a filtration system that recycles urine into drinking water. Solid waste usually gets loaded up and cast off from the space station, along with other trash, in capsules that burn up in the atmosphere. Researchers are trying to find a way to recycle solid waste as well. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
We all know how dangerous electric power lines are if you touch them. But how can birds stand on them and squirrels run on them without being electrocuted? The answer lies in how electricity travels through things. It's a simple law of physics called the path of least resistance. Electricity is basically lazy, and it will always take the easiest path to travel from one place to another. Engineers design wires to make it easy for electricity to travel through them. But obstacles, such as the bodies of birds and squirrels, create resistance. It becomes too much work for electricity to go through the bird and the squirrel to continue its path on the line, so it continues on a straight line. As long as the animals keep all their feet on the same wire and don't touch anything connected to the ground, they won't get zapped. Now here in Tampa, we have an abundance of squirrels and trees. And it's fair to say that with 4 feet and a tail, they sometimes get clumsy and touch a wire and a tree branch at the same time, zapping the squirrel. And sometimes you lose the electricity at your house. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
Yes, black holes of any size can collide. When they get so close together that they can't escape each other's gravity, one black hole merges with the other, and you're left with an even larger black hole. This can be quite a violent event that produces a lot of energy. But get this, up to 5% of that mass gets lost. So time for a little history. The first black hole collision that humans know about was a 29 solar mass black hole, merging with a 36 solar mass black hole. A solar mass is a unit of measurement used to figure out the mass of stars. One solar mass is equal to the mass of our sun. So you ready for something really weird? The black hole that these two black holes created had a final mass of only 62 solar masses. That means that a total of 3 suns worth of mass were gone. So what happened to that 3 solar mass? Where did it go? It was emitted as gravitational waves and sent out in ripples through the universe. Very briefly, for less than a second, 2 merging black holes can actually emit more energy into the universe than all the stars in the universe combined can radiate through their light. It's mind-blowing, right? But there you have it. Any size of black hole can collide with another, from stellar mass black holes to supermassive black holes. But there is no reason to worry about Earth getting sucked up into a black hole. The nearest one is 3,000 light years away. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
Let's discuss boomerangs and the science behind what makes them return to their throwers. The boomerang is one of humanity's oldest, heavier-than-air flying inventions. But have you ever wondered what makes them come back? As you might have guessed, the answer lies in their design. Proper wing design produces the lift necessary for a boomerang's flight. The wings of a boomerang are designed to generate lift as they spin through the air. This is because of the wing's airfoil shape, angle of attack, and beveling on the underside of the wings. The phenomena of gyroscopic precession is responsible for making a boomerang return to its thrower. That is, when a boomerang spins, one wing is moving through the air faster than the other wing as the boomerang moves forward. While the leading wing spins forward, the lift force on that wing is greater than on the wing behind it. This results in an imbalance of force that gradually turns the boomerang. The difference in lift force between the two sides of the boomerang creates a consistent torque that makes the boomerang turn. It soars through the air and slowly loops back around in a circle. And here's an extra tip. To make a boomerang really soar, hold it vertically and give it a good spin. But be careful where you aim. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
Have you ever thought about fish and wondered if they ever get thirsty? Do they get that same urge to drink water the way humans do, despite them living in the water? Are they even able to drink? The answer is no, fish don't get thirsty. Although some fish do drink water, fish in general do not have an urge to drink water. Humans drink to maintain balances in their bodies, particularly the balance between salt and water. If freshwater fish drank water, their balance of salt to water would be thrown off. The water would dilute their blood because they have a higher concentration of salt in their blood than in the water surrounding them. However, their bodies do intake small amounts of water through their gills and skin. Now let's talk about saltwater fish. These fish live in seas and oceans. They are the reverse of freshwater fish because the concentration of salt in their bodies is lower than the concentration of salt in the water they live in. Water ends up moving from their bodies to the surrounding water. Saltwater fish are therefore at risk of dehydration and have to actively drink water through their mouths. Then the water is processed in their bodies. So although saltwater fish drink water, that does not mean they get thirsty. They live in water, so their drinking is not a conscious response to seek water and drink it. In other words, these fish are not drinking because of the driving force of thirst. The answer is fish do not get thirsty, or at least not in the same way that we do. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
Did you know that astronauts in space can be as much as 2 to 3 inches taller than they are on Earth? Gravity and spinal elongation have a lot to do with this phenomenon. Gravity on the Earth compresses your spine like a spring. But in the low gravity of space, the spine opens up the space between the vertebrae in your back, and you grow a little taller. But once you're back on Earth, gravity compresses your vertebrae, and you return to normal height. So if you'd like to be a little taller, at least while you're in space, you might consider becoming an astronaut. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
When you think of the word sky, what comes to mind? Clouds, the color blue, the air we breathe. Stopping to think about what the sky is can bring up the question of whether or not the sky is weightless. I mean, it's kind of floating above our heads, and if it isn't weightless, how much does it actually weigh? And how can that weight be calculated? To answer the first question, the sky is not weightless. Actually, it is much heavier than you might imagine. So think about it. Air is all around us, from the ground all the way up to the top of the sky. That air is not empty. It's composed of gas and molecules have weight to them. The air that makes up the sky, known as the atmosphere, weighs about 5 million billion tons. Are you having some trouble fathoming how much weight that actually is? Well, it would be the equivalent of about 570 trillion adult elephants. We don't get crushed under all that weight because it is evenly distributed over the Earth's large surface. There is, however, weight that presses down on you, and we refer to that as air pressure. And that is approximately 15 pounds on each square inch of your body. So we can measure air pressure with a barometer or a barometer app on your smartphone. Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.
Are you a contact lens or glasses wearer like I am? Unless you were lucky enough to be born with perfect 20/20 vision, then you probably fall into this category. What if there was a way to see without your glasses or contacts? Say, if you were in a pinch or couldn't find them, and you could make a way for yourself to see. There is a quick and easy pinhole trick to correct your own vision without lenses or surgery. All you have to do is make a very tiny hole using your fingers and look through it. See, it works. Everything becomes clear again. And this little tip will work no matter how blurry your vision is. But why does this work? We must first think about how vision works. In order to perceive something, light has to travel from a source, then bounce off an object, then travel to your eye. The light then gets projected onto your retina, where it creates an image of that object. So, when you see something out in front of you, the background and foreground get blurry. The lens in the eye can focus only on light coming from one distance away. If an object is too far or too near, the image will be blurred. The pinhole trick is successful because when light travels through a tiny space, it can be focused from any distance. Since the opening of your fingers is so small, light can only travel through one area. The key here is not focusing the light, but rather blocking it. Did it work when you tried it? Thanks for watching, and I'll see you next time.
Engineering is Everywhere is designed to get you curious about the world around us and encourage you to seek more information on your own.